Imagine a giant, sleeping for 12,000 years, suddenly waking up with a roar that shakes the very ground. That's not a myth or a legend. That's the incredible story of the Hayli Gubbi Volcano in Ethiopia. For millennia, this ancient peak was just a silent giant on the landscape. But recently, it shattered its long slumber in a spectacular and powerful eruption, reminding us all of the raw, untamed power brewing just beneath our feet. Today, we're diving deep into the heart of this geological marvel. We'll explore what happened when Hayli Gubbi woke up, what could have triggered this monumental event after 12 millennia of silence, and how this eruption is changing everything for local communities and even for air travel across the region. This isn't just about rocks and lava. It's a story of history, science, and the sheer force of nature. Let's start by painting a picture. Hayli Gubbi is located in the Afar region of Ethiopia, a place famous for its intense geological activity. This area is part of the East African Rift Valley, a massive crack in the Earth's crust where tectonic plates are literally pulling apart. It's a geological hotspot, home to some of the most fascinating volcanic landscapes on the planet, including the famous Erta Ale lava lake. But even in this active neighborhood, Hayli Gubbi was considered dormant, a relic of a distant past. Its last known activity was around 10,000 BC, to put that in perspective. That's around the time humans were just beginning to develop agriculture. For all of recorded human history, this volcano has been quiet. Until now, the first signs of trouble were subtle. Small tremors, almost unnoticeable at first, began to shake the ground. Then, local communities reported strange rumbling sounds, like distant thunder that wouldn't go away. Scientists and monitoring stations quickly picked up on this unusual activity. The ground around the volcano started to swell, a telltale sign that magma was moving upwards, pushing against the Earth's surface like a balloon being inflated from within. Then, the moment arrived. With a tremendous burst of energy, Hayli Gubbi erupted. A massive column of ash, smoke, and gas shot miles into the sky, transforming the clear blue Ethiopian sky into a dark, swirling canvas of gray and black. This wasn't a gentle awakening. It was a violent roar. Eyewitnesses described a scene straight out of a disaster movie: the ground shaking, a deafening sound, and a sky filled with volcanic debris. The eruption column, a towering pillar of power, was visible for hundreds of miles. So, the big question is, why now? Why, after 12,000 years of peace, did this ancient giant decide to wake up? Geologists are working around the clock to piece together the puzzle. But the leading theory points back to those tectonic plates I mentioned earlier. The constant pulling apart of the African and Arabian plates creates immense stress and weakness in the Earth's crust. This process can create new pathways for magma, molten rock from deep within the Earth's mantle, to rise to the surface. It's likely that a fresh batch of magma, perhaps hotter or more gas-rich than what was previously in the system, forced its way up from the depths. Think of it like shaking a soda can. The gas-rich magma was under immense pressure. As it rose, that pressure was released, causing a highly explosive eruption. This new injection of magma acted as the trigger, reawakening the dormant plumbing system of the volcano and unleashing the energy that had been building for thousands of years. It's a complex process, but it's a powerful reminder that even the most ancient geological features are part of a dynamic, ever-changing planet. The immediate impact of the eruption was dramatic and widespread. The most visible effect was the massive ash cloud. Volcanic ash isn't like the soft ash from a fire. It's made of tiny, sharp fragments of rock and volcanic glass. It's abrasive, corrosive, and when it gets wet, it can be as heavy as concrete. This ash cloud spread across the region, posing a significant threat. For local communities living near the volcano, the situation was dire. Ash rained down, blanketing villages, farms, and water sources. Breathing became difficult as the air filled with fine particles. Livestock, a crucial part of the local economy, were at risk from contaminated grazing land and water. Emergency services and aid organizations rushed to the area, initiating evacuations and providing essentials like clean water, food, and face masks. The eruption turned daily life upside down, forcing thousands to flee their homes with an uncertain future ahead. The impact on these communities is profound and will be felt for years as they work to rebuild their lives and livelihoods on a landscape forever changed. But the effects weren't just local. That enormous ash cloud billowed high into the atmosphere, right into the flight paths of commercial airliners. As we learned from the 2010 eruption of Iceland's Gubbi volcano, volcanic ash is a major hazard for aviation. The fine, sharp particles can melt in the heat of a jet engine and then fuse into a glassy coating on the turbine blades, causing the engine to fail. It's a risk no airline is willing to take. As a result, aviation authorities moved quickly. Airspace over parts of Ethiopia and neighboring countries was closed. Flights were canceled or rerouted, causing a cascade of delays and disruptions that rippled across international travel networks. Passengers were stranded and air cargo was delayed. It was another stark reminder of how a single geological event in one part of the world can have a significant global impact, connecting us all in unexpected ways. Now that the initial, most explosive phase of the eruption has subsided, a new chapter begins: the scientific investigation. For geologists, this eruption is a golden opportunity. It's like a natural laboratory has just opened up, offering a rare chance to study a long-dormant volcanic system as it comes back to life. Teams of scientists are now carefully venturing into the area. They are collecting samples of the newly erupted ash and lava. By analyzing the chemical composition of these materials, they can learn about the magma that fueled the eruption. Where did it come from? How deep was it? What was its temperature and gas content? These clues are vital to understanding the inner workings of the volcano and predicting its future behavior. They are also using a variety of high-tech tools to monitor the volcano. GPS stations track the slightest ground deformation, revealing if more magma is moving underground. Seismometers listen for the faint tremors that signal underground activity. Gas sensors measure the types and amounts of gases like sulfur dioxide being released, which can indicate how much magma is near the surface. All this data is fed into computer models that help scientists assess the ongoing risks and forecast what might happen next. Will there be more eruptions? Will the activity die down? These are the critical questions they are trying to answer. It shows that even landscapes we perceive as permanent and unchanging are, on a geological timescale, constantly in motion. Volcanoes that have been silent for longer than all of written human history can, and do, wake up. This event underscores the importance of volcanic monitoring, especially in geologically active regions like the East African Rift. The more we understand these powerful systems, the better we can prepare for future eruptions and protect the communities that live in their shadow. The story of Hayli Gubbi is still unfolding. What scientists discover in the coming months and years will not only unveil the mysteries of this specific volcano, but will also add to our collective knowledge about the powerful forces that shape our world. It's a humbling reminder of nature's power and a fascinating glimpse into the fiery heart of our planet. Thanks for joining us on this incredible journey to the heart of an awakening giant. If you found this as fascinating as I did, don't forget to like, subscribe, and hit that notification bell so you won't miss our next deep dive into the wonders of our world. See you next time.